now we are going to start with some commercial cells, right. So you know that we use cell batteries in a circuit, we use cells in this thing. It is actually used in many things like torches, watches, calculators. So we are now going to start with some basic cells which we often use. So before we start, you should know that what actually is the battery. What actually is the battery? Battery is nothing but the combination of two or more cells in series. As you know that whenever you use battery, you write in this way, right? A big line indicates the positive terminal and the short one indicates the negative terminal. So battery is actually a combination of two or more cells connected in series. This is what is the battery. And you know that what forms the base, what is the basis of reaction in it? It is obviously oxidation and reduction. That means the redox reaction are taking place in the battery, which leads to the production of energy. So now which battery is called as an useful battery? Like you have many batteries, but which battery will be called as useful battery? The one whose voltage remain constant, means it can work on the same voltage. Second, it should have long life, that means it should work for more time period, and it should be compact and easy to use. So these are the features actually which make any battery as a useful battery, right. So now we know that battery is formed of cells, so we are not going to start that what kind of cells do we observe. So basically if we talk of the cells, we have two kinds of cells. One is the primary cell and other are the secondary cells. One is the primary cells and other is the secondary cells. Primary cells are one in which you can say that they cannot be recharged. That means there will be a spontaneous reaction occurring in them, and or you can say as soon as the reaction stops, the cell actually becomes dead, and no external energy can actually reverse those reactions or can make the cell work again. So I will just write here that primary cells are those in which electrode reactions can't be reversed. We cannot reverse the reaction actually. Once the reactions are finished, the cell becomes actually ultimately it becomes dead and we cannot recharge it. We cannot recharge it. But if we talk about secondary cells, so in this the electrode reactions can actually be reversed. That means we can supply some external energy and we can just reverse the directions, or you can say we can reverse the reactions. We can reverse the reaction or so by telling this that we can reverse the reaction actually, so that means recharging is possible. So that means it can used as many times as we need. But here you can use the cell only up to certain limit, because once the reaction gets exhausted, it becomes dead and there is no external energy which can actually reverse the direct reactions, or you can say which can make the cell work again. So here the cell ultimately becomes dead, and here the recharging never allowed the cell to become dead. So this is what is the primary cell and the secondary cells. So now if we talk about some primary cells, so let us discuss the common primary cells which are used. So out of them, the first cell which we are going to discuss is the dry cell. And the second cell which we will be taking up, which is included in your syllabus, is the mercury cell. So let us first start with the dry cell. So as I told you that it is a primary cell, so obviously there are the spontaneous reactions which are occurring in it, but once the reaction gets exhausted, the reactants get converted into products, you cannot reverse the direction, right. So this is what is the basic thing about the dry cell, that it is a primary cell. So now just look at this, that how it is formed. It is formed of a container, right, which is formed of basically zinc. So there is zinc container acting as the anode, right. This is like that. You have a metal cap here, this is a metal cap, and you have a rod going inside, and this rod is basically a graphite rod. A graphite rod. It is going to act as cathode here. Right. It is surrounded by a black substance. It is surrounded by actually a black substance which is a mixture of MnO2 plus coke. You all know that how coke is obtained. It is actually a pure form of coal obtained by destructive distillation of coal. So there you are using that coke with the manganese dioxide, and you are just surrounding the graphite rod with that. And now here is the electrolyte. Here is the electrolyte, and electrolyte is nothing but a paste of ammonium chloride and zinc chloride. So this is what is the dry cell. I think you got it. It consists of zinc container. It consists, which is acting as a node. It consists of graphite rod. This one is the graphite rod, right? Serving as a cathode, surrounded by you can say the black substance, that is the MnO2 and coke, and the electrolyte which is used is a paste of ammonium chloride and zinc chloride. So this is what is the dry cell. So now we will see that how it actually works here. So what happens at anode, because we know that the spontaneous reaction actually occur in them. So that means at anode, zinc is going to lose an electron, and in order it forms Zn2 positive, right. So now these electrons which the zinc has been given, so this is an oxidation first, then these two electrons will move through the electrolyte, and as they will move to reach the cathode, they will ionize the ammonium ion from the solution. So that means when they are just passing, we have the ammonium ions, we have the chloride ions, we have the zinc ions and the chloride ions. So when the electrons are going to move from here to here, it is going to ionize the ammonium ions. It is going to ionize or discharge the ammonium ions from the electrolyte. So along with the electrons, the ammonium ions will also move there. So what happens at cathode, that ammonium ions plus the MnO2 which act as a depolarizer plus the two electrons, they unite to form ammonia plus a compound that is MnOOH. Here the oxidation state is +4 and here it is +3. So we can say that manganese is actually acting as a depolarizer. Depolarizer is a substance whose oxidation state just gets changed in the electron transfer process. So as you can see that here it got transformed from +4 to +3. So MnO2 act as a depolarizer. And now what happens here, so we will just look for the overall reaction. So if we talk about the overall reaction here, so zinc plus NH4 positive plus MnO2 giving rise to Zn2 positive plus ammonia plus MnOOH, right. This is the overall reaction. You know that actually the ammonia which is evolved here is not a gas actually. It occurs in combination of with zinc, forming the compound like this kind of compound. That means they are occurring in combination with each other, forming this kind of complex. So this is what is the dry cell. I think you got it. So this is the construction. So what happened at anode, the oxidation occurs, the electrons when passed, they just discharge the ammonium ion from the electrolyte, and this kind of reaction occurs at cathode. MnO2 is definitely a depolarizer because its oxidation state is being changed just by an electron transfer process, and overall reaction is something like this. And ammonia here is definitely not a gas. It occurs in combination with zinc, forming this layer. So now one more thing I would like to discuss. You know that sometimes when the reactions are going, when the cell is not in use, again when the cell is not in use, so sometimes this zinc container gets holes in it. Zinc container gets holes in it, due to which there can be a leakage from inside. Due to this there can be a leakage from inside. And when there is leakage, so obviously you can say the cell cannot work on the same potential. So in order to avoid that, what we do is we just provide a lining of iron or steel just to make the cell leak proof. So if you want to make the cell leak proof, you need to cover it with the iron or steel lining so that there should not be any leakage from the cell. So this is what is the dry cell. Now if we talk about the mercury cell, so in mercury cell what happens, again here what we get to see is like I will write here, anode is again the zinc, cathode is HgO, and electrolyte is KOH, and electrolyte is KOH. So what is going to happen here? So the reactions which will occur at anode is definitely Zn plus 2OH negative forming ZnO plus H2O plus 2 electrons, right. So this is the you can say the reaction at anode which is occurring, and what happened now, these things pass on to cathode. Cathode is particularly HgO, it combines with it H2O and 2 electrons liberated from anode, and they just combine to form Hg plus 2OH negative. So this is what is the reaction which is taking place in the mercury cell. So if we want to write the overall reaction, it is Zn, this thing Zn plus HgO forming ZnO plus Hg. So as you can see that this overall reaction do not involve any kind of ions, right. So that means it can work on the constant potential, because look again, in this case what you saw actually, that in this case when the cell was working, the ammonium ions were constantly getting discharged, and they were just reacting at cathode forming NH3. So that means if you talk about the concentration of solution, it was something getting decreased. But here what happens, you can see as there are no ions involved from the electrolyte. So that means the concentration of electrolyte is going to remain as such. And when the concentration of electrolyte is going to remain as such, it means the cell is going to work on the same voltage. And that is approximately equal to 1.5 volts. And the potential for this is varies from 1.2 to 1.5 volt. Right. So these were actually the primary cells. I think you got it, that primary cells are basically those cells in which the reactions which are already taken place, like in here the zinc has been oxidized to Zn2 positive, this has been oxidized to reduced to this thing. You cannot reverse the reaction by supplying with some external energy. So those kind, like as long as these reactions will continue, the cell will keep on working, and at the time when the reactions will cease to occur, the cell will no longer work actually, because it becomes dead. So this is what is the primary cells, and this is very important, the dry cell, right. It is very important, you often come across a question related to the dry cell. So now we will start this we have done. So we are going to start with the secondary cells. Secondary cells, as I told you, they are the cells in which once the electrode reactions have been taken place, you can reverse the direction. That means we can recharge the cell. So just look at the board, that what kind of secondary cells do we get to see.